Hi there, this is Unit 4, Video 7. It's the last video that we have for this graphing unit, and we're going to be working on graphing our two reciprocal functions, the cosecant and secant. These are the detailed, if we applied every sort of shift equation. So it is the same thing that we had for sine, cosine, tangent, and cotangent as far as where the amplitude is. A for amplitude, our B indicates our period change, the H is our phase shift, and the K values here we have as our vertical translations. Also noting that we could have reflections, which would be indicated by the negative in the front. So that sets up exactly the same. What's really important is that we remember that cosecant, abbreviated CSC, is the reciprocal of sine. Extremely important that we remember which one belongs, or which one's a reciprocal of which. And that our secant, abbreviated SEC, is the reciprocal of cosine. Keeping that in mind as we go through this video, I'm going to do a parent function for each of them, and I'm going to do a translated and changed function for each of them with you. At the end of the video, there will be two equations. You'll need to copy those equations into your notes on a separate sheet of paper that you will turn into me. You're going to identify all the information, make a table, and make a graph for those two examples. Again, those are going to be turned in, so make sure they're on a separate sheet of paper. Alright, so here is going to be our parent table and parent graph for our cosecant function. We're going to start with just doing the parent equation, which is CSC of x, so the cosecant of x. Because cosecant is the reciprocal of sine, we are allowed to use the period of 2 pi to complete an entire cycle of this function. So I'm going to start by making this table from 0 to 2 pi for my standard period, with pi in the center, pi over 2, and 3 pi over 2. Next, I'm going to go ahead and I'm going to write down the values for sine. I'm doing this for a reason. Very important that you understand. The values I'm writing right now are the sine values. I'm going to use them to create the table for cosecant. 0, 1, 0, negative 1, 0. The same as we had for sine. I'm going to change colors. And I'm going to change these because we're going to take the reciprocal of all of the y values. So the reciprocal of all of my zeros is undefined, just as it was for tangent or cotangent. But the reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. If I flip over a negative 1, I still get a negative 1. I'm going to go back to my graph here now, and I'm going to plot the sine points. I will always plot the sine points on a cosecant graph. So at 0, I'm at 0. At pi over 2, we're up here at positive 1. Then I will be at 0 for pi. 3 pi over 2, we're down at negative 1. And at 2 pi, we're at 0. So this is exactly my sine curve so far. However, we know that the cosecant is the reciprocal. So I'm going to now graph my reciprocal function, my reciprocal points, if you will. To do that, every place that was a 0 had turned to an undefined, and the way we represent an undefined location was with our asymptotes. So I'm going to place on this graph 3 asymptotes through those points. If this were to continue, there would be more asymptotes, but I'm only looking at one period of my graph. So how do I actually address all of the other points on here that are also being reciprocated? Since 1 stays 1 and negative 1 stays negative 1, it's really the points in between. So what I'm going to model now is actually going to be what is happening. You'll just be able to graph the end result after this. all of these points along the curve, all of the points along the curve here, if I take the reciprocal of them, for example, this point here might represent 1/2. If I take the reciprocal of 1/2, it should be plotted up here at +2. If the point over here, okay, and I were to take the reciprocal of those, it would end up there. Well, the same thing would occur for all of these. They would be relocated to a different location. The reciprocal of this point would end up way up here. So what ends up happening, I'm going to connect these with a different color because I've got a lot going on, is that all of these points get connected above here just as they were connected below. So in purple, that is my cosecant function. Well, the same thing's going to happen, because I'm not going to draw all the little green dots, but all of these get reciprocated. On the next picture, you'll see we got it a little more cleaned up, and all I have to graph, so keep in mind here, all that must be graphed is you must graph the asymptotes, and you must graph the, I'm going to call them parabolas, although they're not by definition parabolas. Those have to be graphed. Your asymptotes and those U-shaped parts. The sine curve does not have to be graphed, okay? That's just to help you locate those points. Let's go ahead to another one. So here I have some changes, and I'm going to first identify those changes with you. So my changes are that I have a period change, and I'm going to take 2 pi and divide it by the b value. So that's 2 pi divided by 2, so my period is pi. I also see a vertical translation of up 1. So to start off, I'm going to start with my period of pi. We'll split that up. Okay. Now you're more than welcome to write all of the signs at 0, 1, 0, -1, and 0. Or since you know I'm taking the reciprocal, then I'm able to then take all of those zeros and write them as undefined. But again, you can take 2 steps to that. If you'd like to write them all as zeros, and then because it's a reciprocal function, then go ahead and change the zeros to undefined, that would be fine. So I'm going to, I changed my period, but I did not move up. So let's go ahead and change that. I'm going to write undefined 2, undefined 0, undefined. And those are the points I'm going to graph. So since I'm starting from 0 and ending at pi, pi over 2, pi over 4, and 3 pi over 4. And I need the points 2 and 0 to be marked. Okay, at my 3 undefined places, I'm going to draw my asymptotes. I have no idea why it does that. I'm sorry. Then I'm going to put my points at 2 and 0 where they belong at pi over 4 and at 3 pi over 4. So at 2 and at 0. And from those 2 points, I know that every point that would have been on this parabolic shape, or the sine curve, is now becoming inverted, and it turns into this U-shape picture. Oh, that's a bad U. And then this one opens down. If you're curious about which one opens up and which one's open down, it's the higher point that will open up and the lower point that will open down. This is all that I would be expecting to see for you to get 100% on this graph. Let's take a look at our secant curve. So once again, I'm giving you the entire secant function with all of the changes, but we're going to start by doing the parent function here, which is just the secant of x. The secant, similar to cosecant, also has, secant is similar to cosecant because it's a reciprocal function, but also it's the reciprocal of cosine, which has a period of 2 pi. So I will start by filling in my table here with a period of 2 pi. I'm going to once again write the cosine values in here. So we had 1, 0, -1, 0, 1, which are the points I have plotted here for us. But because we're taking the reciprocal, I'm going to plot my reciprocal graph, and I'm going to change these zeros to undefineds. So I know I'm going to get the question, so does that mean that secant has 2 undefineds and cosecant has 3 undefineds? Or does secant have 2 asymptotes and cosecant have 3 asymptotes? And my answer to that question is no. They have infinitely many asymptotes. But on a standard period, secant has 2 asymptotes showing. Doesn't mean there aren't more. They're just not in the picture that we're looking at. These functions go on forever and ever. So there's no reason to ask me if they have 2 or 3 asymptotes. So through my undefined points here, which lie on my x-axis, I'm going to draw my vertical asymptotes. Just as we had done with our cosecant function, I'm going to take the reciprocal of all of these points that are along the curve, and they then bounce and reciprocate up. So this function will look kind of totally different than anything we've had. And I think I need to highlight that for you. And this function, this is the part that gets graphed, including your asymptotes. Okay? The curve you see in between the cosecant curve is not necessary to graph, although it does give you some boundaries. If you choose to graph both the original function and the reciprocal function, you need to indicate which one. Or you need to make the cosine lighter. I'll say that again. If you graph the cosine and secant, make the secant darker, so that I can grade it and know that you actually only intended me to graph that part or to grade that part. Let's try one together. So here we've made some changes to the secant graph. So if you need to take a second and go ahead and pause and write down the equation, you know to do that. I've got an amplitude change of 3. My period did not change on this function, but I did shift to the right, so I have a phase shift right, pi over 2, and we did go down 2. So keeping my standard period for sine, cosine, secant, and cosecant as 2 pi, I will start my table. So if you want to start making your table for cosine, you can. If you don't want to make your cosine table, then you can just go straight into the secant table where you would just turn all those zeros into undefineds. I'm going to actually just go ahead and go straight to secant. So I'm going to have 1 undefined, -1 undefined 1. And now I'm going to make my adjustments to this. And I'm going to start with shifting to the right. So I'm going to add pi over 2 to everything. Nothing different from what we've been doing on all of the other functions. The next thing I'm going to do is I'm going to change my amplitude. Remember, we always multiply before we add or subtract. We always stretch before we slide. So I have 3, undefined, -3, undefined 3. And shifting down 2, I'm going to subtract. My undefined still say undefined because you can't move a vertical asymptote to make a difference, and 1. So these are the points I'm going to plot for my secant curve. Start by labeling my axis, making sure everything stays in good equidistant. Oops, that should be 3 pi over 2 on my chart. Sorry. And pi and 2 pi. Okay, so my axis is labeled and I'm ready to start putting some points on there. At pi and 2 pi, I'm going to graph my asymptotes. Remember, if you don't graph your asymptotes, you have not completely graphed this function. Oops. Okay, and at positive, or pi over 2, I'm going to go to +1. At 3 pi over 2, I'm going down to -5. And at 5 pi over 2, we're at 1. Again, the points that are high open up, the points that are low open down. So this point will go up, and this point will go down and continue down there. This is everything you have to show me for you to get 100% on this secant curve. Alright, so here you go. I need you to copy these equations, numbers 5 and 6, on a separate sheet of paper. Identify the important information, the amplitude, the period change, the vertical translations, the phase shift, and if there might be a reflection. Make a chart and graph the functions. Oh, yeah, okay, well, I didn't say graph, but let's graph. I think that's a good idea. I think you guys are going to be great at these. So the first one is a secant, the second a cosecant. I will be collecting these. Please seek additional assistance if you're going to need it.